The objective of this assignment was to produce a mechatronic replication of a factory. This video will highlight 3 main industrial processes that I replicated. They will also show a circuit design flowchart and it actually working. I manufactured a 3-tier structure so that each floor could be taken out separately and studied. Each floor includes technology and STEM related learning features, as well as an outline of the factory processes on the back of the project. When the on-off switch is activated, the LCD display will display floor 1 active. Shortly after this, the LED 1 will go high and light green. Motor 2 is driven by an L29 3D, which is a typical driver motor, and it will be controlled using switch 2 and switch 3. When switch 3 is pressed and it moves down, it will block the LDR, lowering the lux and allowing motor 1 to turn on. The turn 1 direction powering the conveyor, which is displayed using the LCD display. After this, the LCD screen will display a CNC guillotine machine and it will move a servo to represent the blade moving downwards. To allow the circuit to function, I programmed the Genie 18 microcontroller with a flowchart using Circuit Wizard. The flowchart is a linear pattern and includes 2 digital functions and 1 analog. The 2 digital are switch 2 and switch 3, which control the combi lift. The analog decision is the LDR. In the first run of the flowchart, you can see that the analog says no. This is because the lux intensity is still too high for the LDR to turn on the motor. Therefore, when the combi lift covers the LDR, the lux intensity is low and allows the analog decision to say yes, which allows the conveyor and the guillotine to function. Each one is activated high, the circuit will turn on and the LCD display will display floor 2 active and a status LED will light green. When switch 2 is activated, the LCD display will display CNC punching machine, and this will power both motor 1 and motor 2. Motor 2 will turn both directions to display the bed, and motor 1 will turn one direction to display the turret, and motor 3 then will turn on when the CNC press brake switch 3 is turned on. The flowchart works in a linear pattern with 2 digital decisions. The decision 1 powers the first machine, the CNC puncher, and then decision 2 powers the second machine, the CNC press brake. And then this process will repeat until the power is taken off. When the switch is activated, the LED turns green and the LCD display shows floor 3 activate. Then it will show riveting station, and the servo motor 1 will move in 2 directions. After this, then the LCD will show quality control checker, and a flashing LED and a piezo sounder will sound. Following this, the firearm inspection will occur on the LCD display and motor 2 will turn both directions. And then the circuit needs to be reset for it allowed to continue again. To allow the output process circuit to be carried out, I created the following program flowchart. The flowchart is a linear structure which covers each aspect of the output process in relation to the riveting station, quality control checker and the firearm. Each of these aspects are identified using the LCD display. There is only one switch to turn on the process, and the process will run until it reaches the stop function. Then you will have to hit the reset button to restart the program. Overall, I'm happy with how the factory turned out. This factory I feel would be a brilliant asset in the classroom, especially when teaching GCE technology and design as well as other relevant STEM areas. For more information on circuits and flowcharts as well as the fault finding aspects, I would recommend looking at the final report. Thank you for watching.